Hi everyone, we are on Unit 3 still. We're on Day 5 notes, and then the title for the notes today is Factoring, where A is equal to 1. So we're going to spend a couple days on factoring. We're going to learn multiple types of factoring. We already did difference of squares. Today we'll do something else, so we'll just keep adding to this topic. You've seen this before in Algebra 1 or maybe in class so far. But again, we're just going to recap. So on the top here is just a quick kind of like a warm-up, a recap on what we've done so far. So GCF, remember, it could be a number or it could be a variable, or it could be both at the same time. So we've seen examples of that, but it could be a number, it could be a variable, or it could be both. And I'm just making up these two examples to kind of show you. Example 1 right here, let's do 25x squared minus 15. Remember, you want to look for a number, a variable, or both. I noticed that they don't each have variables, so I'm just going to pull out a number. The number that I could take out would be 5. So I'm going to take out a 5 from both of these, pull that 5 to the outside. 5 goes into 25 5 times with x squared. 5 goes into negative 15 negative 3 times. And that is my greatest common factor. Let's just do another one here. Example 2. 4x squared plus 6x. I noticed that both of the terms have x's in them, and I could take out a number. So for this problem, I'm going to go ahead and take out a 2, and then I'm going to take out an x. 2 goes into 4 2 times with an x left over. 2 goes into positive 6, positive 3 times with nothing left over because I took that x out. And that would be my greatest common factor. Okay, on the other side of this chart, it has difference of squares. So things to remember. First thing is must be a negative sign. So between the two terms, it has to be a negative. And then the other thing to remember here is perfect squares. They must be a perfect square. So, okay, again, let's make up some problems here. Example 1. For difference of squares, x squared plus 100. Okay, there are two terms. It's a binomial. This is good. It must have a negative sign. Well, if I look at this, it doesn't have a negative sign. It has a positive. So if you remember, we wrote that this is not factorable. And then that's it. You can't do it. Example 2. Let's just throw another one up here. 3x squared minus 12. I'm looking at this, it's a binomial, it has a minus sign, but 3 is not a perfect square and 12 is not a perfect square. So I'm going to go ahead and do a GCF. So I'm going to take out a 3. When I do that, that's going to leave me with x squared minus 4. And then I can think, okay, it has the minus sign. 1 is a perfect square. 4 is a perfect square. I just have to know how to write this. When I write this, that 3 is going to come in the front. I'm going to separate this into my two factors. Square root of 4 is 2, so they both get the 2's. One is positive and one is negative. And then that is my answer. Okay, here we go. Factoring trinomials where a is equal to 1. All this means when a is equal to 1 is the number in the front here. If you look at, I'm highlighting all these green. The number in the front here is 1. So to be honest with you, these are our simple cases. These are the ones that are easier. They will get harder. Okay, so I'm going to go back to problem 1. This is how I do it. Your teacher might have explained it a little bit differently, but I use the method of guess and check. So what I do is I figure out what multiplies to 3. What multiplies to 3 and adds to 4. And the only thing that multiplies to 3 is 3 and 1. And then I think, okay, how can I combine those to give me a 4? And I can combine those by adding them. So this is the combo I'm going to use. And when I write this, I make my parentheses. I am factoring it, so I need my factors. I separate x squared into x and x, and then we already picked the numbers. We need a positive 3, and we need a positive 1. And that is our answer. If you just are not sure about that or you're confused on that, you can always check your answer, and I'm just going to show you on this one. You can always check your answer by FOILing or by distributing. So I could do x times x, that's x squared, x times 1, that's positive 1x, 3 times x is 3x, and 3 times 1 is 3. And if I just check this really quickly, I combine like terms in the middle, and I get x squared plus 4x plus 3. And that's an exact match to the very beginning problem, and that means we did this correctly because I would get back to where I started. So let's look at the next one. X squared minus 5x plus 4, what multiplies to 4 times 1, and adds to 5. The only way I can get those, I need a negative 5. The only way that I could get those to be a negative 5 is if they're both minuses, because that would give me a negative 5. So then I'm going to go ahead and make my factors here. I'm going to separate x squared into x and x. We already figured out one of them needs a minus 4 and the other needs a minus 1. And you could FOIL it like I did in the red pen on the other one. It would work, but you can always check your work. Okay, the next one. What multiplies to 15 and adds to 2? So 15 and 3, 5 and 3, 15 and 1, and I think those are my only choices. Then I have to pick which combination can give me that negative 2. There's no way 15 and 1 can get me a 2. But I know if I make the 5 a negative and the 3 a positive and I added those together, that would give me a negative 2. So I'm going to use that combination. I'm going to separate x squared into x and x. We already figured out one needs to be a negative 5. The other's got to be a positive 3. And that is our factored form. Okay, the next one, number 4, what multiplies to 36 and adds to 12? Okay, here we go. What multiplies to 36? 36 and 1, 18 times 2, 12 times 3, 9 times 4. And I think that's all of our options. Oh no, I'm missing 6 times 6. Now, there's all of my options. Okay, you want to pick which combination, and you have a lot of choices. Which combination can get you 12? The only combination that I think can get me a 12 is using the 6 and the 6. And if I do them both positive and I add them, that would give me the positive 12 that I want. And then I can make my factors, split up x squared into x and x. One of them has a positive 6, the other has a positive 6. And that would be my factored form. Again, you can FOIL this, do all that multiplying, and check your work, but that should be good. Okay, just going to continue on. The kind of the issue that we run into for people that are struggling with factoring is they want to know kind of a process or what works every single time. And there's not something that works every single time. It is all about practice and getting familiar with these problems. Each problem, it has different numbers, so they're slightly different and the situations change. So I know it's kind of cliche to say practice makes perfect, but it really does. The method for this, or the method that I use, is trial and error. So you just try it until you get it right. Okay, let's keep going. So what multiplies to 10 and adds to 9? Well, 10 times 1 and 5 times 2. I think I'm going to use the 10 and the 1 because if I make the 10 negative and the 1 positive, that gets me the negative 9 that I want. And then I can separate this into my factors. One needs a negative 10, one needs a positive 1. And I'm going to show you one more time if you want to check your work and you want to FOIL this. So if you think that this is good and you want to check your work, you're going to FOIL. So I'm going to do x times x, that's x squared, x times 1, that's 1x, negative 10 times x is negative 10x, negative 10 times 1 is negative 10. I'm going to combine terms in the middle because those are like terms. And then just to show you where I started, I'm going to highlight it yellow. Where I started in the beginning and what I end up with when I check this should be an exact match. If they match those yellow pieces, that means that I did this correctly and my answer is right. So that's how you could check it again. Okay, number 6. What multiplies to 6 and adds to negative 1? 6 times 1 and 3 times 2. Okay, you have to pick and kind of think about which one should you use. I'm going to use 3 and 2. I'm going to make it a -3 and a +2. That gives me the -1 that I want. I'm going to use my factors here. One of them has a -3, one of them has a +2. And again, you can check your work, but that should be okay. Okay, here we go, a little bit more complicated. Number 7. I noticed that in the front, I talked about this in the beginning, it does not have a 1. So let's go ahead and get rid of that 2 by going and doing the GCF. So I'm going to take out a 2. That's going to leave me with x squared plus 2x plus 1. Now I have this trinomial, which I'm underlining, that I want to factor. So what multiplies to 1 and adds to 2? Only thing that multiplies to 1 is 1 times 1, and if I make them both positive, that's going to give me the 2 that I want. So I drop down the 2 in the front, and I do my factors. One of them has a +1, the other one has a +1, and then it's factored. Same thing for my next problem. I noticed that in the front it has a 3, and I also noticed that it has a exponent of 3. We want exponents of 2. So I'm going to do a couple things here. Take out a GCF. I'm going to be taking out a 3x from each piece here. That is going to leave me on the outside 3x inside x squared plus 3x minus 4. I want to factor the trinomial. The trinomial is the part with 3 pieces. What multiplies to 4 and adds to 3. The only thing that's going to work is the 4 and the 1. I'm going to need a +4 and a -1. Don't forget about the 3x in the beginning. Drop that down. Let's make our factors. One of them has a +4. The other one has a -1. Okay, I'm going to go a little bit faster for these last few. This last one is okay. I'm going to go ahead and do what multiplies to 15 and adds to 2. 15 times 1, 5 and 3. I'm going to have a +5 and a -3. When I factor this, that's going to be x plus 5, x minus 3. If you want to pause the video and try this next one on your own, you can, and then just check your work. Well, multiplies to 54. 54 and 1, 27 and 2, 18 and 3, and 9 and 6. I'm going to use 9 and 6 because if they're both negative, that gives me the -15 that I want. I'm going to break this up into x minus 9 and x minus 6, and there's my factored form. Okay, the last two, I'm going to have to do a GCF here. So I'm going to need to take out a 4 from each piece. That's going to leave me with 4 on the outside, x squared plus 2x plus 1 on the inside. I need to factor the trinomial. So what multiplies to 1 and adds to 2? Well, if they're both positive, that should work. Drop down the 4 in the front. Separate this into your factors. One of them is going to have a +1. The other one is going to have a +1. And there's my factored form. Same thing for this next one. I need to take out a GCF. I'm going to take out a 5 from each piece. So when I write this, the 5 is going to come in the front. That's going to have x squared plus 2x minus 3. I want to factor the trinomial. So what multiplies to 3 and adds to 2. The only way I'm going to make this work is if the 3 is positive and the 1 is negative. So when I write my final answer here, the 5 comes in the front, or stays in the front. I separate x squared into x and x. One of them has a +3, the other one has a -1. And then there's my factored form. Again, check on Canvas to see what your assignment is. Maybe you have an exit slip, maybe you have a discussion board. Make sure you are completing those. If you need to rewatch the video, rewind it, rewatch it, try some of these problems on your own, and then maybe check your work. Don't forget about the worksheet. That's another good place to do problems. Factoring is usually challenging for people, so maybe if you want to take advantage of just Googling how to factor or YouTubing it to find other examples, that would be a good way to just to get more exposure to the material.